13.2, a sector area shortcut. Lynn and Elena are trying to find the area of the shaded sector of the image. Lynn says, we've found sector areas where the central angle is given in degrees, but here it's in radians. Should I start by finding the area of the full circle? Elena says, I saw someone using the formula 1/2 r squared theta, where theta is the measure of the angle in radians and r is the radius, but I don't know where that came from. So for number one, they want us to compare and contrast. Compare and contrast finding sector areas for central angles measured in degrees and those measured in radians. I need a glass of water. Okay. So let's try showing it both of those ways. So radians and degrees. So what they want us to do here is sort of show, is this new method that Elena's talking about, where we use theta in radians, is that going to work for us? So the first thing I want to do is, it's going to be confusing if I use theta in both of my formulas when it represents different things. So I'm going to say theta 1 is equal to the angle measure in radians. And we'll have theta 2 be equal to the angle measure in degrees. When we have a variable, technically, I guess it could represent multiple units. If you have a variable for temperature, it could be Celsius or Fahrenheit. But I think it's easier to understand, to differentiate if I use theta 1 and theta 2. All right, so for my first formula, we've got 1/2 r squared times theta 1. So we've got really all the information we need already given to us. They've given us the radius and they've given us the measure of the angle in radians. So it's 1/2 12 squared times 3 pi over 4. And we're going to want to keep it in terms of pi as always. So let me simplify this a little bit further. Technically, this is 12 squared over 1, just because I've got 3 fractions, so I kind of want to combine them. So it's really 1 times 12 squared, which is 144, times 3 pi. Let's put that in parentheses to really demonstrate it's separate. And then 2 times 1 times 4 is 8. All right, great. Hopefully I'm not making any mistakes. Now I can do 144 times 3 since... Actually, let's see if 144 is divisible by 8. That might make our lives a little bit easier. And it is, so I can get rid of my fraction. Since 144 divided by 8 is 18, I can really just write 18 times 3 times pi. And then 18 times 3 is 54. So did they give us the unit? They said the radius is 12, so they didn't give us the unit. So I'm just going to say 54 pi is my area of the sector. That's if that formula works. Let's actually use a method we know, and that would be much more helpful in proving this works or not. Although technically it could just be a one-off, right? You'd have to show it works several different times, or prove it algebraically to show it really works all the time. All right, but this is a good method to start off. So this formula we know to be theta 2 over 360 times pi r squared. Okay. So to do this problem, I have to convert from radians to degrees. So you could do that a number of ways. For me, the easiest thing is thinking of half a circle as pi radians. This is 3/4 of pi, and I know pi radians is really equal to 180 degrees. So I really want 3/4 of 180. That's 135. So my degree measure for this problem is 135 degrees over 360. So times pi, and I know 12 squared is just 144, because I already did that. All right, let's do 135 divided by 360. That doesn't look pretty, and it's prettiest. 3/8. All right, which makes sense, right? Because if it's 3/4 of half, it'll be 3 parts of all together, which would be 8 parts. The whole thing. All right, so multiply that by 144 pi over 1. And I can already see this is going to be the same because we did 144 times 3 pi over 8, and now we're doing 3 times 144 pi over 8 again. So it's going to be exactly the same. Let's just try it differently. Let's see what if we do 3 times 144 first. Obviously it'll be the same because of order of operations, but it's 432. And 432 divided by 8 is 54. So we get the same answer as before, which is a good indication that whoever told Elena about this formula was right. And that actually is nice. It almost looks like a simpler formula than this, because I don't have to deal with any fraction. Well, I guess the radian measure is a fraction itself, but I think it's a little bit easier to use that. All right, so number 2, explain why the formula that Elena saw works. Okay, I'm sorry, confused by number 3. Okay, I don't know why number 3 is asking to find the area of the sector. We did that. Okay, so explain why the formula that Elena saw works. So let's compare the two formulas again. We got theta 1 over, it's just theta 1 on its own, times r squared times 1/2. And on the other hand, we've got theta 2 over 360 times pi r squared. So we know that this formula works because it's just taking the fraction of the circle times the total area. It's very clear. This one is a little bit trickier because it actually doesn't show the pi, like where the pi comes into play. We don't see pi r squared, which we would expect to see when we're calculating area. So if I can show that this formula is the same as this formula, that would prove that it would work all the time. So the main difference between these two formulas right now is that we've got theta 1 and theta 2. So if I could find out what theta 1 is in terms of theta 2, that would go a long way to try and get this formula to look a bit more like this. So if we think about it, we've got theta 1 radians. And I want to end up in theta 2 units, which is really degrees, right? So I got to think of a way that I'm going to get rid of radians. And this is really comes down to unit conversion. We can multiply by any fraction that demonstrates a proportionality between radians and degrees. What I mean by that is, if I want to get rid of radians, I want to multiply by a fraction where radians is in the bottom of my fraction, because then they'll cancel out. So my easiest conversion is I know I have pi radians. That would be 180 degrees. This is like I showed before in the last lesson, where you can multiply radians by 180 over pi and it will cancel them out. So I know if I do this, radians is going to cancel out and I'll be left with theta 1 times 180 over pi is equal to theta 2. Okay, so let's see if when I plug this in for theta 2, I end up getting that formula over there. So that's a big fraction to plug in. Theta times 180 over pi, and that is actually over 360, yikes, times pi r squared. Unfortunately, dealing with fractions is part of life. But thankfully this is not that bad. When you have a fraction like this, where it's a fraction over another fraction, the bottom fraction you can really just multiply by the denominator, because this is really 1 over 360. So what I can do is I got theta 1 times 180, and that'll all be over 360 times pi. and of course times pi r squared, which since it's just a regular number, we can put over 1. And so hopefully you guys see that we can cancel these pi's out, which is a welcome sight. And 180 over 360 is just 1/2. So I'm going to reduce that fraction to 1/2 times theta 1 times radius squared. And we can see that that's exactly the same formula that we have over here. So since we used equations that we already knew, this proves that this formula is correct that Elena saw. The one thing you just need to know is this only works if theta is in radians, and this one only works if theta is in degrees. We already found the area of the sector up here, so we're done with that. All right, that's all for 13.2.